Assalamualaikum everyone. Welcome to my video tutorial for high school physics students. In this episode, we analyze the relationship between linear and rotational quantities in kinematics. So just stick around, watch, and learn. The question is, a superhero swings a magic hammer over her head in a horizontal plane. The end of the hammer moves around a circular path of radius 1.50 meters at an angular speed of 6.00 radians per second. As the superhero swings the hammer, she then ascends vertically at a constant 2.00 meters per second. Question letter A. What is the speed of the end of the hammer relative to the ground? And question letter B. What is the acceleration, both in magnitude and direction, of the end of the hammer? We imagine the superhero swinging a magic hammer over her head in a horizontal XY plane. We idealize the tip of the hammer to be a particle moving in uniform circular motion parallel to the XY plane. We also assume a counterclockwise direction of the rotational motion of the particle with a constant angular speed omega. At this arbitrarily chosen point P, point P is in the circular path. The tangential speed, denoted by v sub tan, is directed horizontally in the negative x-axis. While whirling the hammer, Harley Quinn ascends vertically at a constant velocity, which we denote as v sub y. In this top view sketch, v sub y is directed toward the reader as emphasized by the dot symbol, or we say v sub y is directed into the positive z-axis. The resultant velocity of the particle, denoted here by v sub tip, because we're talking about the velocity of the tip of the hammer, assumed to be a particle. All right? So this resultant velocity, v sub tip, becomes the vector sum of v sub tan and v sub y, where v sub tan and v sub y are perpendicular to each other. And since the angular velocity omega is constant, the only component of the linear acceleration is a of r, all right? Also known as the centripetal acceleration of the particle. It has no tangential acceleration because, as we said, the angular velocity omega is constant. All right, so we represent the radial acceleration by this red arrow, all right, denoted by the symbol ace of R, all right. Notice that this radial acceleration is directed toward the center of the circular path, or what we call the axis of rotation. Emphasizing the given data in information, we have the radius r equal to 1.50 meters, which is how far from the tip of the hammer, all right, is the axis of rotation, all right. And we also have the angular speed or velocity, omega, which is equal to 6.00 radians per second. While swinging the hammer, Harley Quinn ascends with a constant vertical speed of 2.00 meters per second. Okay, so this speed v sub y, all right, is also considered to be the vertical speed of the tip of the hammer, and this is perpendicular to the tangential velocity v sub tan of the tip of the hammer. Our target variables are the speed v sub tip, all right? So v sub tip is actually the vector sum of the tangential velocity and v sub y, all right? The vertical velocity of the hammer. We also would like to determine the linear acceleration of the tip of the hammer, denoted by a sub tip, all right? So this is the acceleration, all right, of the tip of the hammer. And in our earlier diagram or illustration, all right, we also identified this as the radial component of the acceleration, all right. So this is also more commonly known as the centripetal acceleration, meaning its direction is towards the center of the circular path or the axis of rotation. So how do we go about determining these two target variables? All right. The actual linear speed v sub tip, okay, will be computed based on the fact that v sub tip is equal to the vector sum of the vertical velocity of the particle v sub y and the tangential velocity v sub tan. All right, where this tangential velocity is just the product of the angular speed or angular velocity omega and the radius r. We can also calculate for the acceleration of the hammer a sub tip or a sub r, okay, using this equation. A sub r equal to the square of the angular velocity multiplied by the radius r. And the fact that the angular velocity omega is constant, right? We emphasize that there is no tangential acceleration. So a sub tan is equal to 0. Moving on now to our calculations. The tangential speed v sub tan, all right, is equal to the angular speed omega multiplied by the radius r. So substituting, we have 6.00 radian per second, that's the value of omega, times the value of the radius r, 1.50 meters. So, doing our math, we will get the value of the tangential velocity v-ton equal to 9.00 meters per second. So, we can calculate for the resultant speed v sub tip, alright, using the Pythagorean formula. Alright, v sub tip, or the magnitude of the velocity of the tip of the hammer, okay, equals square root of uh, the square of 2.00 meter per second plus the square of 9.00 meters per second. Okay, 2.00 meter per second is the value of the vertical velocity of the hammer tip, v sub y, and 9.00 meter per second is the computed value for the tangential velocity, or v-ton. So again, simplifying, we will get the value of the velocity v sub tip equal to 9.22 meters per second with two significant figures. And finally, we can now calculate for the acceleration a sub tip, or a sub r, which is equal to the square of omega times the radius r. So substituting, we have the square of 6.00 radian per second times 1.50 meters, and we will get, all right, the magnitude of the acceleration of the tip, the hammer, equal to 54.0 meters per second squared, again in three significant figures. So by definition, this is directed towards the axis of rotation. Alright, so for evaluation, with this acceleration of the tip of the hammer equal to 54.0 meter per second squared, we say that based on Newton's second law, or F net equals ma, the superhero Harley Quinn must exert a force of 54.0 newtons on each kilogram of the hammer at its tip. And before we finally end, here's the key concept that we applied in this problem. If a rotating rigid body is also moving as a whole through space, just use vector addition to find the velocity of a point on the rigid body. And that ends our tutorial. Till the next episode, inshallah. Thank you very much for watching. Please follow me in my FB page, and please don't forget to subscribe to my YouTube channel.